Welcome friends, myself Dr. Shyam Gore from Department of Electronics, DSM College, Chintur, affiliated to Swami Ramanand Tirth Marathwada University, Nanded. Today we are discussing about the electronics paper number 6, amplifiers. Especially in this discussion, we are going to see about the DC load line. And the maximum distorted output. So, when we are discussing about the DC load line, first of all, we have to know about the characteristics of the transistor. And the characteristics of the transistor means the relation between the voltage across emitter and collector and the current flowing through the collector. So, the characteristics of the transistors are like this. This is the y-axis, this is the x-axis. We are taking the VCC, that is the collector to emitter voltage on x-axis, and the collector current on y-axis. When we are giving some input current, that is the IB, suppose the IB is equal to 2 microampere at that time, suppose we get the IC, and if that IC is equal to 2 milliampere. Similarly, if the base current is increases, then the collector current is also increases. Similarly, in this way, when we are increasing the base current, the collector current is also increases, like this. So, these are the output characteristics of the transistor, and in this way we are getting the collector current with respect to the input current, that is the base current, and this is the output characteristics of the transistor. And in this output characteristics, if we draw the line that is from the cutoff point and the saturation point, here this is the cutoff point and the saturation point. That point A is known as the cutoff point and point B is known as the saturation point. So these are the 2 points on the characteristics of the transistor, and the voltage equation for the collector and emitter is the VCC is equal to IC into RC plus VCE, and from that equation we get the IC, and that IC is equal to VCC divided by RL minus VCE divided by RL. Now consider the 2 cases. If you are looking towards this point A, that is the cutoff point, and point B is the saturation point, and at a point A the IC is equal to the 0. This is the 2 extreme cases in the characteristics of the transistor. At a point A we have the collector current, that collector current is equal to the 0. Okay, and when we substitute the value of IC is equal to 0 in this equation, that equation is IC is equal to VCC divided by RL minus VCE divided